So we know a gravitational attractive force will act on them, mutual attractive force. We know what is a gravitational force. It's a mutual attractive force. And in what action will act? Towards each other. So both will accelerate. Why accelerations are different? Because masses are different. After some time, we see that they both undergone some displacement, you know. So let the separation between them, or we'll do one thing. We'll write this is say some R. Okay, now it has become X separation. Both have undergone displacement, no? Then here, if I go and check it, no, again some other force will be acting because the interaction, the distance between them has changed here. Now they will acquire, they'll be moving with a speed V1 and V2. They were released from rest. Earlier released from rest. Now they start moving towards each other. Now how much of each has moved? Again center of mass, the core idea. Suppose say let's take M1 greater than M2. Where the center of mass of system will be? Where the center of mass of system. So what is this? This will be the center of mass of system. The star mark, I'll put it here now. What is C? C is the center of mass. What is the net force acting on system? Will be zero, no? So this will undergo a displacement of how much? Say R1. This will undergo a displacement of say R2. Now, so many multiple ideas will be introduced here. You have to be careful. Okay, now from where this kinetic energy they acquired? What energy has decreased? As there is some interaction potential energy, what we call. The potential energy, the interaction potential energy got decreased. The decrease in interaction potential energy got converted into the increase in kinetic energy. Straight away, I'm taking you to the concept here. Means like they were released from rest. They have now kinetic energy. From where this kinetic energy came into the existence, some other energy should decrease. What is that? It's a potential energy. And moreover, this gravitational force is a conservative force. So we can apply conservation of mechanical energy. So what is that interaction potential energy? It is denoted by symbol in short. I'll write it by U, and it is given by G M1 M2 by R square. What do you mean by negative sign? Means it's an interactive force. To tell you that it's an interactive force. So how do you can say, sir, there's an interactive force? I mean, this potentially from where you brought it. So let me just generalize it. I'll differentiate this du by dr. It is r only. If I differentiate this, r to power of -1, so that will become positive, and this will become how much? R square. Am I right? If I differentiate this with respect to r, I'll end up with this equation. And what is G M1 M2 by R square? It should be the force. It should be the force. And now you can bring that one. So why that negative sign? To tell you that it is a interaction potential energy. It's a conservative field. That's why that negative we are bringing it. And this force is what now? It's an attractive force. That's what the F is what we took that one. So like this, what happened? Like that, what when we'll get expression for this interaction potential. This one means like I can justify now. So why do this forces come? The field does work. Because of the field does work, as the field does work, the kinetic energy of particle increases. The field does work means the field must have potential energy, must have energy. That energy possessed in the field I'll call as interaction potential energy. Very simplified way I'm trying to bring it. This one. How you can keep one particle in the book. There, what they did, they kept one particle at rest. They release this particle, then this will accelerate. As it accelerates, since it's having a mass, so its speed will increase. So kinetic energy increases. So from where this kinetic energy will come? Because this force is doing work. This force is doing work means it must possess potential energy. So how to express that potential energy? So finally they ended up with this equation. When it is at infinity, force will be zero. When it's at distance, our force will be non-zero. They derived it. So I think straight away, let me write it here. Because again, in electrostatics, we'll go in detail. No, it may not be needed now here. So definitely, I'm the same thing. So like I said, how you can say that work done? You can see from here again, F into dr. What is F into dr? dw. Everything revolves here only, no? Everything revolves here only, that one. So like this, what is the interaction potential given by this particular formula? Minus g m1 m2 if two particles are separated by distance r. So what is the interaction potential energy? It is equal to minus g m1 m2 r, that one. Okay, let's come for this one. If more than two particles. Now what do you mean by negative sign? It's a closed system. It's a bounded system, to tell you that. It's a bounded system, that one. Now if there are more than two particles are there,